let's start, David, if we could, with you and sort of your experience at the highest level. Talk about the nexus between what needs to happen in this space and its technology conversions and upgrades and public policy. We've heard a lot of people talk about different things like renewable portfolio standards, deregulated versus non-restructured markets. How much does that matter? Where does that fit into this conversation of taking next steps?
First off, I want to say that my marketing team is very worried that I'm here because they're not here, and they're worried that I'm going to say something very inflammatory or politically incorrect. So I apologize beforehand. I tend to do that. They know that. But you hit on it earlier. It's where does quality capital go? You know, how do we foster an environment where people are willing to invest? So what makes a good investment is a foundation for policy and standards, and then the ability to grow and extend off of that. So that requires two things. And what we're working with our clients on right now is how do we go back to establishing for a utility those deregulated entities that are able to go off and leverage some of the knowledge, the capital that's been developed in our industry. That's one. Two is the new market entrants. These are probably the most dynamic and scary entities in our industry because they're able to move very fast. And that dynamic between, and both have their pros and cons and their capabilities and weaknesses, but it's those two entities that get me excited about this industry. So absolutely, start the standards, create the foundation, and then let's see what we can do with the knowledge base that exists within 100 years of growth. And then the new dynamics of the telcos coming in, the cable companies coming in, the solar companies coming in. We've heard about them all over the past day and a half. That's where true creativity and innovation and economic return makes sense. So my business is all about how do we extend the rate of return beyond the regulated standards. And so that's what gets me excited. That's where, you know, hopefully today we'll have some conversation about how our industry fosters that kind of growth. And I will tell you one thing, if we can't do it within our utilities themselves, the third-party entrants will do it for us. And they're already there. And they're very good and very fast.
Yeah, I think I like to call them the barbarians at the gate, right? Mm-hmm. It's the utility industry has been sort of I guess it's sort of a cloistered industry, right? It's one of the last ones that really minds its own affairs. You know, I think of all the time I've spent at the Technical Advisory Committee at the ERCOT Board of Directors where, you know, we write our own rules of the game, by and large. There is government oversight more and more all the time, tragically sort of turning into a game of cops and robbers more than a collaborative, you know, overseer versus, you know, and market participant venture. But you make a great point. I mean, getting the policies right, and you got to work on those standards, but bringing those people in, it's the ideas that sort of force the evolution. Now, Clinton, you've done some work on these barbarians at the gate, right? Trying to bring these new models into places where policies allow it. Talk a little bit about how you survey that landscape, how you find those opportunities, where you see challenges that you should just leave for another day.
Yeah, that's a great question. So if we look at, sort of before we move forward, if you look back at the business model challenges, I think someone mentioned on the last panel about Sam Insull and some of the things that were going on in the late 1800s, early 1900s. We went through some of the same process of even railways consumed almost 50% of the power electronics that were being developed in the industry at the turn of the century. And if you look at what happened, they actually started selling their excess capacity to customers nearby. So they're actually threatening the big central generators, you know, vertically integrated utilities at the time by selling their excess capacity. And so if you look at the textile industry, it was the same way. They all owned their own distributed generation. And so at the same time, they were going through the exact same process that we're talking about now with distributed generation and how to commercialize this, whether or not independent people can actually serve each other's electricity. And the regulators were saying, is this safe? Is this practical? Should we get involved? Should we not? So I think we're seeing the second wave of that. If I think about some of the business models that we've seen globally, a lot of what's going on in Europe, Northern Europe, Central Europe, is some of the business models that are being changed due to transmission and distribution operators needing to operate the grid reliably. So you have reserve-type products to where people can provide services to instantly turn on generation. And what's going on right now that we see is an opportunity for a little bit of a change in that in the way that they interact with retailers. And so, for example, before the distribution network operators weren't really being active in providing these reserve products, the ability to back up the transmission system. And now we see a lot more interaction with these new aggregators that are coming in and changing it. And so now the distribution network operators are saying, well, am I a distribution system operator that's providing system level services? And if so, can I interact with those retailers or the aggregators to provide that service through my network to a transmission operator? So I think those links in between those three systems are now starting to blur, and people are getting innovative into how to solve that problem of we need reliability due to all the onset of renewables, but we need to also account for how each one of those players makes money and keeps reliability up. And so we see that that's a real big change that's going on in the industry right now.
You know, you raise the issue that, you know, for the transmission system operator or for the, you know, an independent system operator, you know, type organization, you know, now these guys are held to an evolving set of North American Electric Reliability Council standards that carry weighty penalties, real sanctions, real enforcement around it. These guys have got a heavy responsibility on them, and you're talking about, well, why can't we plug into your machine? Why can't we play on your grid? Now, Mike, you're sort of the keeper of what we call the Common Information Model, or the CIM, at ERCOT, the Texas power grid operator, and I have run face first into your model. Mm-hmm. I worked on the interconnection of the first battery, grid-scale battery in Texas, sure. the No Trees facility out in West Texas, and when it was time to go through that process and load that unit into the model said, I'm sorry, Dave, we don't have a category for storage. We had to work around that. Sure. But go more to Clinton's. I want into your system, but you've got to guard your system and make sure it's reliable, and lots of people have to use it. What are you trying to balance there? How do we get the right system evolutionary model in place?
Sure, that's a great question. And I guess let me start with a quick story and kind of to answer your earlier question about my title. So basically, I'm a psychologist turned engineer. And what had happened was back in 2003, I was doing some laundry back in New York, throwing coins in washers and dryers, and the last dryer and the lights go out. So it wasn't just me flipping a breaker, it was the Northeast blackout of 2003. Being a ham radio guy, I ended up in the control room and actually saw what happens to society when the lights go out. So just at a very high level, there's always this constant balance that we're trying to make between the innovation, whether it's entrepreneurship, intrapreneurship, and just hardcore reliability. There's always the drive, internally, externally, all around for growth, but trying to balance that to make sure that we don't add too much risk. So, as an example, with that SIM discussion, as with most things, when you're using kind of a cutting-edge technology, I would kind of reframe it as, look what's going right. We have this kind of reaction, this kind of interaction, where we can find these kind of deficits in the system and strive to, kind of collaboratively make them better. And as we do that, because we're tied into this standard, we're also benefiting the standard. And sort of as you multiply that process out over time, you end up with this collaborative standard that gets more and more robust and starts to serve more and more use cases.
You make a great point. I mean, the development of the standards, I've been a participant for a long time in developing, the market protocols of ERCOT or the operating guides of ERCOT. There's a lot of technical standards baked into that. That's a laborious process, and as stakeholders, we generally like each other and get along and try to collaborate. Now, George, you've had a lot of experience in the development of standards across, a number of different, industries and practice areas. Why are they so dang hard to get everybody on the same page? Why does it take so long?
Well, there are other models for doing standards that are different and that can get things done more quickly and without all this, debate and consensus. And I'd contrast China's approach to developing the smart grid to the U.S. And I would characterize China's approach as sort of the old AT&T monopoly approach to standards. What we're trying to do with the smart grid in the U.S. is more of the internet model. And while we have to safeguard the reliability, the integrity of the grid, we also want to enable innovation. We want to enable interoperability so that new technologies can be integrated into the grid as they become available without having to throw out legacy stuff. So in China, you basically have one, there are really two utilities, but one of them serves 90% of the country, so it's the big dog, State Grid Corporation of China. They have their own R&D organization, which is sort of similar to the Bell Labs of AT&T, and they basically develop all the standards. They don't have to reach consensus among lots of stakeholders. They just decide what they want to do, and they do it. So in the US, even if we wanted to, it wouldn't be practical to approach things that way because we've got 3,000 utilities. There are very different needs depending on, munis and co-ops are very different than the IOUs. So, and we also want to encourage innovation. And we want, in the US, our approach is getting all the stakeholders together at the table. So, I mean, usually it's the technical people, but more and more we're getting the regulators involved. So the approach that we've taken, which I think many people are aware of, is NIST was given the responsibility by Congress back in 2007 to convene a process to provide some orchestration of this, and that process has moved along quite well, and it was always the plan to basically get this set up and then hand it off to a private sector entity. And so we've got today the Smart Grid Interoperability Panel, which is set up as a not-for-profit corporation. John McDonald, who's here in the audience, is the chairman of the board. It's a self-governing organization. But government agencies, NIST, DOE, Homeland Security are participants. The regulators participate, both state. Ray Palmer from FERC staff is a participant. So the process is getting all of the stakeholders together, and the end result is that while we have lots of sort of individual technical standards, the SIM, for example, there's IEEE standards, there's IEC standards, you need to have some overall vision for how does this tie together. What are the priorities when things don't move along quickly enough? What levers do you need to pull to move them faster? That's the job of the SGIP. So that's the mechanism that we're using in the US to provide this overall orchestration, working with about 20 different individual standards bodies that deal with individual aspects of the smart grid. Unfortunately, the process does not always move as fast as one would like. So the problem that you mentioned with the SIM is just a timing problem that the standard hadn't quite caught up to the market requirement. And this is where the SGIP plays a role in trying to say, well, we've got to get this moving more quickly. The other factor that is different than the internet is that in the internet there are a couple of mantras for standards development. One is the internet originally was supposed to function as best effort service, right? It's doing things now it was never designed to do, so I don't think that's necessarily the motto anymore. But there was another motto, rough consensus and running code. Well, I don't think the electric grid, there are safety issues, reliability issues. We need a little more robust process than that, and that's one of the reasons it does run a little more slowly.
That totally makes sense. One of the things I'm curious about is in that process that y'all are working through, what are some of the major near-term milestones that the process hopes to accomplish?
Well, so you look at the big picture. I think the most critical standards that are needed for the system to work end to end and allow for innovation are the standards at the interfaces across the major domains. So the standards that cross the meter, if you will, are really critical to get into place so that people on the customer side of the meter, the appliance manufacturers, demand response providers and so forth can develop that market. So you look at standards like the Smart Energy Profile, which is more of a residential kind of home energy management, home automation type of application. ADR, which is more of the commercial and industrial. Those are really critical standards, and I mean they're moving along, not as quickly as anybody would like, but they're starting to gel. Certainly, the cybersecurity standards. There was a panel earlier on that are critical, and a really hot area that is again not moving along as quickly as everyone would like are the standards relating to interconnection of distributed generation, solar PV. And here's a case where we're trying to introduce new functionality, smart inverters that can provide grid support. We want inverters that can, a lot of people were upset because they couldn't, in Sandy, in New Jersey, people couldn't use their solar PV systems, right? Because, islanding was, not something you can, for safety reasons. So the standards need to catch up to that. The work is there. Some of the regulators aren't really, as engaged as they need to be. So I'd say to a large degree, there's a timing problem and an education problem, but I think we're getting there.
To a large extent, when you think about the complexity of mapping that universe and then harmonizing that universe, it's a daunting challenge, right? Efran, you've worked across this space where standards of this system and standards of this system don't make it particularly easy for the two systems to work together. Continue this theme for us along the integration, not just of systems, but of systems of systems.
So the challenge that we are facing in this industry is that we have very well-intentioned technical people who work in very, very small silos. And yet their salaries are paid from some economic momentum in the society. So those economic sources actually traverse multiple environments. So if you take applications like demand response, or if you take electric vehicles, or if you take distribution automation, those kinds of applications, they're business applications that help the bottom line for organizations. But since they traverse multiple environments that actually accommodate multiple standards at different logical layers, if you take the Gridwise Architecture Council framework. So what you have basically is a matrix of multiple standards at different layers across multiple environments. And in order for the business application to be supported, these standards have to move from PowerPoint into actual test beds, where these things can be tested across those multiple environments, not a la carte like in a lab at a university or at a national lab, but actually in real infrastructure. So this will help us cross that chasm. Quite often, like in the dialogue I'm hearing, we've got the early adopters, and then we were waiting for that elevator for mass commercialization. But in between is a chasm, and to cross that requires an open infrastructure where these applications can be tested as systems. There are several such opportunities coming up as a result of the stimulus funding. You will see that at Illinois Institute of Technology. You'll see that at University of California, San Diego, and several others. I'm involved in one at the Philadelphia Navy Yard called the GridStar, where we have an unregulated grid with a substation, a distribution line, a smart home, EV charging, and storage. It's infrastructure waiting for this kind of testing. And my hope is that we can go across these various institutions that address different standards in different environments and different layers, bring them together in collaborative research to take this concept from PowerPoint to where vendors and utilities can see minimum risk in deploying them. Otherwise, we're just going to see for a while some excitement amongst technology connoisseurs, and then it'll die down because economic necessity will drive the way things will happen.
You raise an interesting point too. I mean, it's not just traversing systems in a technical way. It's not just working through the engineering. It's not just working through the IT logic, but it's also working through sort of the development life cycle of the technologies themselves. You talked about the path of commercialization. That's something that's been a theme here as well. And Jose, that's an area where you've had some experience, is taking these areas where the research is occurring, the academic environment, the corporate world, different models, public-private partnerships, entrepreneurial models, large corporate structures, organized markets, emerging markets. Talk a little bit about why it's important to work through all those different spaces, how they work together, and where the gaps are where they don't quite fit together very well.
Yeah, I mean, I think that one of the things that we learned here in Austin, my previous life working in economic development for the Austin Chamber, is that in order to build these new industry sectors, you do have to have buy-in from all the major stakeholders, and you really, if you want to create changes and innovation on the power grid, you have to include, of course, the utility. You have to include the local industry, academia. You have to include all the relevant stakeholders to have success in doing that. And so one thing that we did here in Austin was we developed a grassroots effort to bring about change and innovation in smart grid. And 5 years ago, we launched an initiative called, well, originally we called it Pecan Street Project. Now it's called Pecan Street Inc. And we banded together all the local stakeholders. We went after Department of Energy funding through the stimulus program. We raised about initially $10.5 million. And that money went into testing out new home energy monitoring systems. We developed a whole big data, data analytics, data visualization platform to understand how homeowners are using energy within their homes, and the utility had a vested interest in this. The university was involved. About $1 million a year of that funding was transferred to the university to further understand how residential homes and commercial businesses are utilizing energy and how to better offset peak demand and what new technologies we could implement on the grid. Without involving all the stakeholders, we would never had the opportunity to build this brand new industry here in Austin. And we also had to include the existing industry. We know that we are a high-tech city, but we also had to include the wireless technology industry, semiconductors, computer industry, and really bring some of these established technology sectors to the table and say, what can your technology bring to smart grid? And how can you help us truly redesign the energy infrastructure and truly help Austin Energy, our local utility, city-owned utility, become the utility of the future. So it was a comprehensive effort that we went through to really understand how we can drive about change in this industry sector. And you mentioned China earlier. I visited China a couple of years ago, and it is a very top-down approach, highly regulated. And they will, the Chinese utilities will decide which cities and which economic development zones will be the beneficiary of the investment in the grid infrastructure. But I think here in the United States, with the deregulation that we've seen in Texas, and even with the regulated utilities like Austin Energy, you see the demand there for homeowners, residential customers, commercial customers wanting to take more control over their utility bills. And I think that is what's really driving the change, but you do have to have a comprehensive plan in place that ties together economic development, creating jobs, creating an environment for startup companies in this space to emerge and get funded and create new technologies, but also the existing companies to engage and be a part of it. And kind of where we are today, Pecan Street has grown to include well over 1,000 customers, and we're branching out to cities across the country and monitoring in real time energy usage all across the country. So this is something that was truly a grassroots effort, and I think that is, as far as my experience goes, that's really how you you go about driving change and building new technologies and new infrastructure.
Jose, you brought up the investment. We all saw a ton of investment happen over the past 5 years in our industry. The challenge we've been facing, and actually I think what you're starting to solve, is as an industry, we tend to love to plug things together, and when it works, we declare victory. And this goes well beyond that. It's 90% of our industry plugs it together and says, great, it works. Don't touch it. The other 10% says, wow, what can I do with this? And that's what we need to foster more of.
And maybe onto that about the other 10%, you look at regulated business, and since my role right now is in distribution, I think all the time about regulation, and you compare information that's being used in non-regulated businesses. Like I did an experiment last week with my friend who's into policy for data security information laws, and I turned off all my security settings to basically wide open on my social media. And I adopted a Doberman Pinscher last weekend, and sending messages out and things like that. Well, today I actually received a message, an advertisement for a training of working dogs. So this was something to where I didn't post it on posts on Facebook or other social media, but emails and texts and other things. So if you think about how well someone can segment me and tell me exactly what I need and market to someone, that is a whole nother level. And I'm not advocating for completely wide open with respect to electricity consumption. But if you think about some of the standards and privacy that I think progress could be made on those standards to make people aware and comfortable with sharing information, then once people are comfortable with sharing that type of information, then innovation will really take off in being able to use that to correctly segment someone. I mean, to not send energy efficiency or HVAC programs to someone living on the coast, like many people send right now, right? We're really bad at segmenting in the electricity space, energy in general right now. So I think that's a big piece of standards that people don't talk about is privacy and sharing of this information that could unlock a whole lot of innovation on the retail side and other products such as, tell me when I need to upgrade my air conditioning unit. Or people can tell you when you need to change your air filter on your air conditioning unit. There's all these things that go along with that I think come under greater visibility when you have things like NIST being sold to Google and about information sharing. And I think it is a good thing to start talking about is how can we get consumers comfortable with the right level of information sharing for themselves so that we can see that same level of innovation that we see in the traditional retail marketing environment.
Yeah.
And there's a fundamental question too, isn't there, about will we be able to do anything with that once they serve it up? I mean, let's assume that George's process produces some common standards to which technology can operate and interface with each other. Let's say that the Internet of Things becomes the thing that we all suspect it may become. I'm curious about the guys, Mike, your folks sitting out there at ERCOT. Can you do anything with that? I mean, if I understand the lay of the land correctly today, you can't tell me how much distributed solar generation is on the ERCOT grid today.
So that's a good question. And with, of course, the usual engineer answer, which is it depends.
Of course.
But I think that really, what I'm hearing here is a part of something much bigger, which is that there's a fundamental shift in the way that we're thinking about the grid. It's not, someone is the provider and someone is the customer, but that you're actually building a relationship. So as an example, one of the things that we did, for those of you in Texas, you may remember back in February of 2011, when we had rolling blackouts, people started becoming aware of, here's this power grid. It's not infinite, neither is our internet or our gas pipelines or a lot of other, things that we use that gives us high quality of life. But there's a fundamental hunger for people to feel a part of the system and to be a part of the system. So as an example, we have a mobile app where we can send conservation alerts and ask for help. And we've actually seen at the transmission level. So for those of you who don't know, the way that ERCOT is structured, based on NERC guidelines, anything below, say, 69,000 volts falls into the distribution area, so we don't really see it in that context. So certainly it's the case that we don't know, how many, homes, for example, have how much solar, especially, in certain areas of Texas. But at a much higher level, what we're trying to do is answer the question, what is this neighborhood going to do? And part of the answer is solar, part of it is the temperature and air conditioning and so forth. But there's also a hunger to kind of build that, top to bottom relationship where as an energy customer, I can talk to my local utility and I can participate in Pecan Street and I can participate in the thermostat, adjustment program and so forth, but also I can talk to my ISO, to my grid provider, and just kind of get a high-level view for what's going on, because ultimately I'm a part of the system and the system's a part of my life. So kind of bridging those pieces together.
David, I suspect that you would say that the people who are going to step up and fill that space, make that connection, give those customers that tool, do that empowering, are going to be the wild-eyed entrepreneurs waving copies of an Ayn Rand novel around, right? I mean, who are those people, and how are they going to make that connection? Where's the focus and what's required to succeed in that nexus?
Well, our industry certainly has its fair share of crazy professors out there. They're good, and they go out and do those wild-eyed things, and they're getting backing. The Silicon Valley is taking notice of what we're doing, and the whole word clean tech came up, fairly recently, and it became a big investment buzz. Now, but the other side of it, and really the side I want to see happen, is that some of the people that have a tremendous advantage are the utilities themselves. The ones that can establish some people and harness the knowledge inside those utilities. If we could figure out how to harness well, let me take a step back. If you look at, for instance, some of the people that are mining internet data and getting customer information, and they're working very hard to get that information. Utilities have been working with customer information for years, and we're very good at it. So why can't we pull the best and brightest out of the utility industry, establish those dereg entities that are able to go out and harness the embedded knowledge that we've developed? So I see it on two sides. Yes, you've got the wild-eyed entrepreneurs, and they are going to attract capital. But you have to have the partnerships, the structure, the embedded knowledge of the industry to make it really pay off. I think it's a symbiotic relationship. We just need to foster the utilities to those that are willing to go there to get a little bit out of their shell and extend themselves. We're already seeing it happen. Certain utilities here, we see representation from those utilities. And they're establishing creative thinking. They're going above and beyond. They will be the ones to establish rates of return above and beyond what their boards have been expecting or what the regulators have mandated they get. So I like both sides of that equation, and the people that can actually bring those two pieces together have a competitive advantage in the market.
Kind of an open question, or maybe I'll go to you on this, Efran, but is there a point at which we can go no further with the sharing, we can go no further with the integration because the security threshold is crossed? It seems to me that, so often, when we were introducing wind power to the ERCOT system, you were like, hey, 1,000 megawatts, man, that's all. Right? Well, I mean, we're spending 11,000 megawatts today, so don't give me that crap. But reliability is the R card for a reason. You put the R card on the table, and everybody goes, ooh. Cybersecurity is what it is. So, can we find the balance?
Yeah, I think that we're looking for equilibrium at the wrong point. I think that if you have very proprietary environments that vendors may think that they're getting an advantage in the market, are actually doing a disservice to themselves. They're limiting the size of the market as a result of this proprietary environment. Remember that standards, by definition, are a best practice. You cannot have a best practice unless you have a practice. And a practice is not a science experiment in a lab. So I wanted to pick up on one of the points George made about the urgency of deploying some of these standards. We don't have the luxury of time. If you look at the RPS targets across the country and you start thinking about as they become 25, 30+% in renewable energy, most of that is not going to come from hydro. It's going to come from solar, wind, and those kinds of things, which are very intermittent. So you're taking an electrical system that was traditionally a passive system where beyond a certain point you didn't worry, the electrons knew where to go. Now you have an active controlled network in which you have to use nonlinear control theory and informatics to balance this out in real time. If you try to do that in a multi-vendor environment where there are proprietary protocols running, where's the situational awareness to really make that informatics work? So there is a disconnect there. So what I would like to suggest is that maybe standards and established standards with clear interfaces for information exchange at certain points, like where IEEE 1547 meets DNP3, or where it meets IEC 61850, where 61850 with field equipment meets SIM, or where OpenADR coming into a house meets Smart Energy Profile. Not only do we have to have clear interfaces for information or data exchange, but we also have to have cybersecurity controls that are consistent, because you cannot say that you have a secure cybersecurity posture and have these variations in the level of security. Only standards assure you some consistency across this fabric.
Mike, did you want to respond to something in there?
Oh, sure. Well, I was going to say that that's certainly, one of the things that at ERCOT we've looked at and, have kind of developed a little bit of an entrepreneurial kind of idea to try and take, exactly as you described, these kinds of more complicated, higher rate, higher depth data and create situation awareness tools out of it. I think that one of the challenges of the industry is also the joy of the industry. I mean, there is so much good that you can do. There's so much excitement, and you can really make people's lives better. But to me, it always comes down to, for those of you who've taken psychology, to Maslow's hierarchy. When you get the safety part of the pyramid, the bottom part solid, you can keep going up and up and up and making things better, innovating and improving. So there's kind of that. To me, it's less of a tension and more of a collaboration, how we kind of dovetail all of that energy to make sure that everything that we do, passes that litmus test and then keeps progressing.
The example that I want to give, if you've ever traveled in a third world country and try to go through an airport, see how many times they ask you for your passport and see how many times your tag on your bags are stamped. I mean, by the time you get to the plane, you're well decorated. And yet, when incidents occur, you find out that the route was some airport in Malta or somewhere where the flight came and the questionable individual was there because it was an inside job. When you look in industrialized societies, besides that check, when you are getting your boarding pass and then at the security, the rest of the time you're being watched. But they're using advanced technology and situational awareness to see, are you going to do anything odd? Just try walking in a wing that is you're not supposed to go there. You'll get a security guy coming pretty soon. So we can use technology and standards as a way of creating situational awareness that gives us better security than security by obscurity.
And security theater.
Yeah.
Yeah, definitely security theater. So we're at about, I guess, sort of the 15-minute mark till we're supposed to wrap, I think. Is that right? Is somebody watching my time? Yeah. 20? Okay. Okay, so we could still go for a little bit, but we'll start taking questions from you guys here in a minute if you wanted to, if you have any, feel free. There's a microphone at which you may cue.
One thing I wanted to add on, because that security thing is important to me. What I have seen happen at a few different utilities is when you have a lack of a standard or a lack of an understanding or open areas where you can define things differently between different utilities, sometimes I've seen utilities retrench to whatever is the most defensive approach they can take. And it's almost to the point where we can't satisfy some of the needs of innovation in the marketplace if we lock down everything we have so that there is no creativity, there is no innovation out there. I'm specifically dealing with how we have defined NERC-CIP in different regions of the country right now. NERC-CIP could be defined as no data leaves the premises. Oh my gosh, if I do that, one, everything's 3 times as expensive as what I could do before. We foster no innovation for cloud or new environments. It's been an extremely frustrating thing. And there's always somebody in the utility that start raising their hands and saying, hey, no, we need to lock down everything. And to a certain extent, everybody's kind of afraid of that guy. It's the cybersecurity czar that you don't want to cross his path because he can make life difficult for you. We've got to get beyond that, and so to a certain extent, that's where the foundation. I'm looking for the help from the standards committees to say no, we can go beyond it. We've done it here, we've done it elsewhere. Places like ERCOT, that's really important for us because we look at ERCOT as a standard in the industry of how we protect our infrastructure for the country.
Yeah, so if I could just pick up on that, this is an example where the standards need to continue to evolve, right? So an ironclad requirement like that isn't really risk-based, and when you look at the NIST framework, the DOE risk management model for the electric utility industry, these are risk-based standards. So you need to look at the situation, evaluate what's the risk to your business, and then apply the appropriate judgment call there. And the NERC-CIP standards are evolving. Version 5 is moving much more in this direction. So again, this is when I first took on the standards job for NIST in this area, I often got the question from the political officials, when are the standards going to be done? And they were very uncomfortable with, well, like never, Right. The internet's been around for 40 years and the standards are continuing to evolve, and that's going to be the case here.
Yeah, no, that's clearly true. You raise an interesting issue there in that space, though. I mean, at the grid operator level, there are defined stakeholder processes. There's a way to vote and call the question and move on. You can have winners and losers. Ultimately, you have political leadership that's arbiters of disputes. But at a level below that, at the distributed scale level in particular, sort of to a point that Clinton made earlier, is that you're in the land of fiefdoms at that point, right? I mean, it's their system and no one else's, and its interconnectivity to the rest of the universe is somewhat limited, right? And so there are gatekeepers, and they're not afraid to show you that they hold the key in their hand, right? I mean, can we ever turn, Clinton, the challenges we face in that feudal universe into a more progressive, solution-oriented, methodical process to get to good integration answers?
Yeah, I think so. If you look at, I think one of the first steps is looking at it from a business perspective. You take even distribution, big challenge right now, if you look at solar, right? And you look at the Western Council of Executives, and they're writing letters saying, just give me a standard inverter that I know can connect, standards-based, and I can have visibility into it. So if you think about what is of the concern of the distribution company, and the grid operators with NERC-CIP, and we know it's going to go down into the distribution world. I think it is critical to think about, well, what is critical information that's related to the reliable operation of the network, and look at those real business problems and say, I need for something to create a secure connection to the grid. And if it does it automatically, like I do with my cell phone when I go travel all the way around the world, even better, right? And if you can get the manufacturers on the same page at a regulatory and standards-based level, I think that's when you start seeing these business problems go away. Otherwise, you look at infrastructure upgrades like they're doing in Germany right now, to where now they've got to upgrade all of these inverters. And the cost of that is massive. So I think when you get the producers, you get the standards along with the regulatory oversight to make that change happen, that's when some of these things really open up.
So
I just wanted to add that I think that the demand for open access from consumers, from customers, from citizens, I think will drive the utility industry to integrate more and to collaborate more with other industries. And one thing that I see coming very quickly is the integration of the automotive industry into the power grid, especially with the adoption of electric vehicles. And also at the University of Texas, we have a great research center called the Center for Transportation Research, and they're working on autonomous vehicles and the network that you need for traffic management systems. And that plays right into cybersecurity, data being transferred from vehicles to the grid, to the internet. And I think those things, eventually the convergence of all these different industries will require the utilities to be more open access and be more of a participant.
I think that as an industry, we need to change our mental models about what standards mean. We tend to have a very geeky concept of standards. And yes, in the lower layers, if you want to talk about Phi and Mac layer and the OSI model, those standards are very geeky. But as you go up in the GWAC stack, up into the business process and policy, those standards are more like narratives. They're like instructions to allow people to be in the right zip code. And quite often we'll ignore those, or we will let each organization figure it out on their own. Now, the problem with that is, look at the frequency of natural disasters. Now, a utility, when it faces a natural disaster, doesn't have enough workforce to deal with all the damage that occurs. So quite often, contractors come, emergency workers come to help them in those situations. Now, if you don't have established standards, imagine the downtime as you train these people in your proprietary way of doing something. Forget the cybersecurity vulnerabilities that exist when you've lowered the guard enough for all these third-party people to work with you. And Centerpoint has an amazing case study, if you want to see, in how they've developed procedures for those emergency operations. And those are standards too. So I would ask you to widen your concept of what a standard is so it doesn't look like the big bad wolf. This actually can help maintain an organization's economic viability, which is ultimately the final arbiter here.
Do we have some questions? Yeah, let's take one.
Hi, my name is Marita. I'm from Environmental Defense Fund, and we're working, among other things, on trying to basically enable and engage consumers in this space. And I'm curious in terms of new business models and kind of the relationships changing that you had mentioned, and also Clinton, kind of the ideas of just privacy and the way networks now are, where everything seems to be wide open. How can we monetize the information sharing for consumers and value propositions that consumers can see in that space beyond just sort of vague notions of saving money here and there, but actually them being integrated into the economic fold of all of this, as their data, which is owned by them, is actually a commodity they can leverage?
I would love to get my hands on data that shows me whose pool pump is going bad, who's got a refrigerator in their garage that's 20 years old. We can tell what's happening there by the information. And so for us, it's really, but we can't cross the boundary in that the consumer owns their data. You don't want to get bombarded by a bunch of different companies out there all trying to sell you something. But to a certain extent, that's where the utility can come in and provide tremendous value and watch out for the best interests of their users. I would love to see the utilities step up with that kind of responsibility. In the Midwest right now, we're just in the process. We've kind of seen our grid get more robust on the West Coast, kind of around the edges of the country. In the center of the country, we're seeing that happen right now in Illinois, Michigan, and now Pennsylvania as well. And those utilities are starting to say, how do I provide extra services to my commercial and industrial customers? Commercial and industrial always go first because they're easier, we can keep our hands around it. That's where we're starting to see take responsibility for
You're talking about the smaller residential consumers would be last. But to your earlier point, I mean, if the utilities don't, if the utilities can't, NIST will, Google will, others will, right? I mean, somebody will. In some respects, you know, there's a race on to identify that value, to connect with that customer, and to loop them into the habit of engaging in this way or through this platform. And, you know, I wonder if these entities born of the 1920s, regulated since the 1970s, who in customer service surveys that span industries typically don't rank really, really high on the customer loyalty factor. Can they get there first? Or is there a whole new breed of people, a whole new class of company, a whole new industry sector that's going to come in and say, nah, too slow. I got this one. Glenn, you got some thoughts on that?
Yeah, so I think that is really interesting. If you look at part of the question of reliability and then the other side of cost and what they can do, I think I start seeing these two worlds combine a little bit. You take the example of the producer. There's a great video that was produced like a couple years ago about how they were making a video, I believe it was a music video production, and he calls in and you know, it's a classic example of the utility didn't know when the time to restore was going to be. So he's sitting there saying, I'm spending all this money, I don't know when it's going to come back on, I just need to know, do I send my crew home or not, right? And I think that they're, in the world of reliability, you start getting the social aspect of, well, do we have a block party, you know, down at the adjacent neighborhood because their power's on? Yeah, there's some privacy, there's some security issues associated with that as well. But people are already providing this information on Facebook, on Twitter, about outages, where they're seeing it, and all that sorts of things. So I think as the reliability question starts mirroring with the economics and even the social aspect of, you know, show me what else I can do today because my power's out and it's not going to be on for, you know, seven days. At the next city over, I can go see a concert or do whatever and, you know, make my life better. So I think that's really what it's about is, can we provide services that are going to make people's lives better by using some of this information?
While watching the creep factor, right? I mean, if I open my freezer and my utility sends me a coupon for Bluebell, I'll be like, all right.
Yeah, I was creeped out by the ad about the dog that I received, you know, the dog training that I received today, right? That creeps me out. So it's got to be on the terms that we understand and are comfortable with, right?
Human level. Can we take another question?
Hi, my name is Ari Khan, and I'm with BEST, and we do energy consulting. But before this life, I was in cancer genomics, and I worked on this project called the Cancer Genome Atlas. I was in charge of the data coordinating center. And so basically there were all these different groups all around the world, and they were all doing research on cancer genomes, and they were looking at it in different ways. And they all had to provide their data to the world in such a way that people could understand it. And so my job was to come up with standards, right? And we were dealing with very sensitive data, right? These are people's genomes. You can identify people by them. So you had to have certain authorization, right, and authentication to get to it. You had to have policies to get to it. You have to have policies to do everything. And we had meetings once a year, twice a year sometimes, where everybody would come together in the same room, and they'd all work together on what those policies were and how people would interact together. And now, so it was a success, and it became a springboard, and now there are these companies that are being just developed just based on the data. And so my question to you is there anything like this happening in the energy sector as far as a data coordinating center, as far as national meetings where people come together to figure out what these policies are, to figure out what the data standards are? What's happening?
Right. So what I'd like to say is that if we go in that direction, that won't be a good direction to go in. This idea of highly centralized architectures for data, the whole idea behind security, you can put the best cybersecurity controls, but if you have a highly centralized architecture, someone is going to jump over that fence and compromise lots of data. So what you want to do is distribute the intelligence, distribute the data out there, push it out to the edge as much as possible, lower the strategic value of data so that the hacker only gets very little amounts. What you were doing was collaborative research, in which case you needed to bring the data together in order to learn from each other. So that's a different business model. Here, even though the tendency for Moore's law is to bring things, processing, bring it all centralized, it's very efficient. But for the sake of cybersecurity and privacy, I would recommend just the opposite. Keep it out there, make it on a need-to-know basis, bring up summaries if you need to, back up, but keep the raw data as out there as possible. Because if you try to highly centralize it, and especially with the inside threat now, with industrial espionage rings and other entities, all the security controls are useless because you've given them the trust as the employee. So you have to, as Reagan would say, trust but verify. So you have to do the situational awareness. You got to break up the problem as much as possible. So that's what I would suggest, rather than coming up with a lot of controls for a highly centralized architecture.
But how do you figure out how you're going to interconnect, right? So you're talking about having data standards, or having standards, having policies. How do you figure out how are we all going to do this? Okay, so let's decentralize it. Let's make it so that you can only get little chunks of the data. But let's say that I was authorized, right? And I wanted to get a hold of that data. How am I going to get a hold of it?
I mean, companies like
how are we going to make use of
Capgemini
it?
do this for a living.
Let me chime in on this one. So this is actually a field that's been well worked in the electric sector, information privacy principles. And there are some global principles. The OECD has fair information privacy practices. There's the Canadian province of Ontario Privacy Commissioner as a whole, privacy by design, which is widely used. If you look at the NIST cybersecurity guidelines for the smart grid, there's a publication called NIST IR 7628. If you Google that, you can find it. There's a whole volume of that on privacy. And since in the U.S., to a large degree, these issues are really regulated at the state level, you have to go down to that level of detail to understand how they apply to different distribution utilities. But that reference that I gave you actually has a summary of all of the relevant regulations and legislation that deal with information privacy for the electric sector. So it is complicated, but it's a well understood area.
Yeah, so there is the document that George is talking about is based on use cases. And that's very important, is to understand the transactions and the actors and on what interfaces, and have well-posed requirements on those interfaces, both in terms of information exchange and cybersecurity credentials. And the concept of need to know really limits, it's like a little cone in a whole sphere. When you do need to know and you put in use cases, you have very few, very limited actors, and everybody else is considered a possible threat. So there are ways of controlling that.
Well, with that, I think we have reached the end of this session. Please, a hand for our panelists who did a great job. Thank you, gentlemen, very much. And thank you all for your attendance and participation.